So here we're looking at impulse. Okay, so impulse is effectively equal to, in words, okay, the force applied to an object multiplied by the time the force is applied. Okay, so the time the force is applied. Now, that's it here. Impulse is essentially force times change in time. Now we know that from Newton's second law that F equals ma. So therefore impulse is equal to mat. And we know that for acceleration it's v minus u over t. So mv minus u over t times t. And then we can see that the times will cancel, and that it's just mv minus mu. Which is equal to change of momentum. Okay, so it's not multiplied by anything, it's actually impulse is equal to change of momentum. So 600 kg mass has a force of 20 newtons applied to it. If it starts from rest, how long will it take to reach a velocity of 5 meters per second? You're going to use impulse to solve this. So what we're going to work out first is, well, what is the change of momentum? Okay, originally it starts from rest, so that's its initial, and what's its final? Its final is going to be 600 times 5. Okay, so that's your final minus your initial momentum. Okay, so what you're going to get is 3,000 Newton seconds is our impulse, our impulse or our change of momentum. Now, because change of momentum equals impulse, so impulse equals change of momentum, which equals 3,000. Well, we could say that our impulse, which is force times change in time, equals 3,000. And our force is 20 times change in time equals 3,000. So our time, therefore, is equal to 150 seconds. So here's a question looking at a rugby player who gets tackled to the ground. Okay, so 70 kg going at 7 meters per second and he's stopped by the tackles. Remember, there's final velocity is 0. Okay, the change of momentum, so that's final minus initial. So 0 minus his initial, which is 70, his mass times his velocity. So in this case we get negative. So we get negative 490 ns. Don't have to do Newton seconds, you could do kg ms to negative 1 as well. State the impulse on the rugby player, same answer. So remember, impulse is equal to change of momentum, so therefore it's equal to 490 ns. If the collision lasts 0.9 seconds, what is the average force on the player? So force is equal to impulse over time. So 490 divided 0.9, and you get about 544 newtons. Sorry, run out of room. Okay, 544 newtons. Now, interesting though is if you increase that time of the collision, then your force will decrease. Okay, so if you extend your collision, remember your force will decrease. We'll talk about collisions more in the class about that sort of thing, especially like why we use airbags and crumple zones in cars.